Hi, good morning, good afternoon, and good evening, everyone. And thank you for taking time to join us today at the Build with Mercury technical workshop session. And it's actually the first community event that we are having for the Mercury Hackathon today. Before we begin, and as I mentioned, for those who have actually arrived a little bit earlier as well, do scan the QR code that you see on the bottom right of the corner of your screen, and to join us at the ice-breaking activity. Apart from that, I would recommend that if you are accessing the session via a web browser, you can go and key in the URL of www.menti.com and enter the code 4447824. This will help us to find out a little bit more about you today, and let's move on as well. So today, we have over here with us actually two speakers. One is Yusuf, who is from Protocol Labs, and the other will be Nik from Decentology team, who will be sharing in a bit, what they have installed for you, to help you be more well equipped and to be able to understand a little bit more about both the NFT storage and also what you can do to start on DappStarter. Before we begin, let's join quickly. Just one last chance to reminder for you to either scan the QR code or go to the browser with the mentimeter.com and entering the code of 4447824, just so that we can find out a little bit more about yourself. So the first question that we have for today is, tell us a little bit more about how you're feeling today. We have people who have actually answered that they are feeling excited, they are fantastic, they feel awesome, and it's actually amazing. And really thank you all for taking the time today to join us as well. The next question will then be on where are you from? Just hold on. Sorry, technical issues. And sorry, the next question is, tell us more where you're from. We do have a wide range of people who are based in different countries joining us today. We have people from Japan, India, Singapore, the Philippines, the Sri Lanka, and Pakistan who will be joining us. And it's great to see that people from all around the world are joining us. To help us a little bit more to get a sense of what you are here for the hackathon and what kind of challenge that you are staying. Let us see what is the track that you're going for. So we have the majority of the people, almost 60% of people who are actually working on the Filecoin and Flow integration project. That's really great to hear. We have about a third of people who are attempting the Flow track and a few more who are attempting the Filecoin track. So I hope for today's session, once we are done with today's session, it will help us to give you a greater insight on how you can start working on either one of the projects, or specifically if you're working on an integration project, you will be able to understand how you can actually approach the matter and to really come up with something that is really innovative and something that will change the world. Last question is really to help us to understand a bit more from what do you need for this hackathon itself. And we do have the options of resources to read, more talk time with mentors apart from the mentor topics hours. Of that, I will cover it later on after the sessions to cover some of the important information for the hackathon. And also, we can relook at how we can introduce more technical sessions by both Filecoin and Flow as well. And do remember to keep these responses coming in, even though you have just joined us. So for those who have just joined us today, before I introduce and welcome the speakers who will be joining us for tonight or morning in your case, do remember to go to a browser and key in www.menti.com and to put in the code of 4447824 to actually help us fill up these 4 questions that we have seen so far. Right, now that that's kind of out of the way, let us talk a little bit more about why we are here today, and really more importantly that we are here today because you are all interested in one way or the other on the blockchain space, or more specifically on Filecoin and Flow. Be it that you are an experienced developer or you are just beginning and exploring your interest as a developer, we are really here today at Mercury Hackathon on finding out how we can innovate, redefine the boundaries, and to build amazing technologies together. So just a quick recap on the 3 tracks that's available for the hackathon itself. The first one is the integration of both Filecoin and Flow, decentralized storage technology with NFTs, and you'll be able to see the price pool over here that's up to $61,000 worth of Filecoin and Flow tokens up for grabs. The second track will be on the best use of Filecoin and or IPFS and or the following decentralized storage services, which you can work on, and you'll be able to submit projects if you are working solely on the Filecoin technology. Last but not least, it will be on Flow. We are looking at how you can have the best implementation of blockchain-enabled applications built on Flow across different consumer-facing NFT dApps, creator-oriented services, crypto primitives with Decentology tools, and more. So without further ado, let me invite the first speaker that we have for today, Yusuf Napora, who is a software engineer at Protocol Labs. And today he will bring you through a 45-minute session to talk more on the NFT storage. Yusuf, please.
Hey, thank you so much. It's great to be here. Let me go ahead and share my screen and get started. So, yeah, I'm Yusuf, and I am an engineer at Protocol Labs. We make some decentralized file sharing and storage technologies that are, you probably heard about in the course of this hackathon. So IPFS and Filecoin are both Protocol Labs creations. And today I'm here to talk about a service that we stood up earlier this year called Nft Storage, and sort of get into why we built it, what actually it is, and then how you can use it. So my interest in NFTs, it really did start earlier this year, although again, I was sort of aware of them, but they kind of obviously blew up in the public consciousness, beginning of this year, sort of. And we at Protocol Labs were really happy to find that people were using IPFS to link their NFTs to off-chain data, because a lot of NFTs are a mix of both information stored in a blockchain and information that lives off-chain, and the link between them can happen in a number of ways. So, for example, like NBA Top Shot, when what's recorded on the blockchain is a moment ID, just a unique identifier for a particular NFT, and then to render the actual moment, the NBA Top Shot site will correlate that with a video clip and so on. So, or another popular alternative is just to store a HTTP link inside the blockchain record, and from there go to some image or video asset that lives elsewhere. But there's the option of also using IPFS, which is similar to HTTP in that your content lives elsewhere, but it has some really cool features that make it a better fit for NFTs, in our opinion, than a sort of traditional HTTP link, especially if you're optimizing for decentralization, like in the sense of like, you would like all of the content of the NFT to be both like available to anybody so that it can be sort of like truly owned by the recipient of the NFT, and also not really dependent on any single service or server. So that's not everybody that's building NFT applications has those particular goals, but those are the kind of goals that are in the wheelhouse of Protocol Labs, is to sort of encourage this kind of decentralization and also provide the tools to make it easy for people to do it. So that's kind of part of the motivation for NFT storage. And as we got into the NFT space, people were using IPFS, we sort of realized that there were some friction points, right? So before NFT storage existed, the people were using IPFS to store their NFTs, and there, there was some issues with that we think the NFT storage can address, and especially the integration of Filecoin. So I'm going to briefly talk about how IPFS alone fits into the mix, and then talk about how Filecoin adds to the equation and how you can leverage the whole thing with NFT storage. So with IPFS, right, it is the interplanetary file system, although at the moment it is still intraplanetary, I suppose. It's been around for a few years, and the way it works is you give each piece of content a unique identifier called a content ID. And this ID is derived from the content. So it goes through a cryptographic hash function, and then it spits out this opaque string of seeming gibberish that will always be produced if you feed the same content into the IPFS hashing algorithm. So the real power of this is that you don't need to split the world into domains and namespaces and servers and things like that. Every single piece of content in the world can be addressed with this one naming system. So it also gives you a pretty interesting property of nobody can alter the data without it being immediately obvious. So if I send a request out for this particular content ID and somebody gives me back some other piece of data, I can instantly tell that this is not a match, and I can just reject it and say something was wrong. Maybe like a bit got flipped in transit, or somebody has altered the data intentionally or something like that. So with IPFS, that can't really happen. Like the key is directly tied to the value. And that's kind of an interesting property, because it means that if I have a link in, for example, blockchain, and once it's written, I can't change the link, right? But if the link is an HTTP link, the value on the other end of the link could change at any time, right? There's no way to guarantee that an HTTP server is going to return the same response tomorrow that it did today. And as a result, it kind of makes the durability of the NFT record a little bit shaky, because while the record of ownership itself is permanent, it depends upon this link to an external system, and the link itself is not especially permanent or static. So with IPFS, you do get these sort of eternal links, like an IPFS CID will always point to this one piece of content. And what's kind of cool is that you don't have to get it from any particular place. So here, one IPFS node is saying, hey, does anybody have this content ID? And this person, this node over here does. So it's going to respond with the content in question and just send it over the wire. And if it's an especially large piece of content, the requesting node might broadcast, hey, who has this chunk and this chunk and this chunk, and like all the little pieces of the file that I need. And those could come from anywhere, and potentially multiple different nodes could be throwing data at you all at once. So in some ways, it can be more efficient than HTTP, depending on how popular the content is and how widely distributed it is throughout the network. So now that this person has requested the content, it can serve it to anybody else. And so this third node here can ask, again, it just broadcasts a request to everybody who's got my stuff. And now both of these nodes are able to respond and return the goods. And that's pretty cool. And it means that the original node could actually disappear, and it's not really a big deal, because these other guys here have the content and are primed to respond to those requests. But then there was a caveat, and the caveat is that all the nodes could potentially go away. And in that case, the content will not resolve. And that's kind of a problem for IPFS alone, because IPFS is a permissionless peer-to-peer system, and there's no constraint in place that you have to stay online forever. It's sort of a everybody is chipping in to share and distribute this information. So it is possible that some piece of content could disappear from IPFS if nobody's actually online holding it. And then the second caveat is this thing called garbage collection, where when the data is distributed throughout the network, those copies, like when I fetch a piece of content and then I'm going to serve it to somebody else, those are temporary copies that could potentially disappear if my disk gets full. And you can prevent that by pinning content and saying, hey, my IPFS node, please remember this particular piece of content. Even if you get a little short on disk space, please don't clear it out. So that's pretty cool. And like, but those two caveats are why a lot of the IPFS usage was going through third-party services, like a pinning service who would host your content for you, pin it, and keep it online forever. And that, or as long as your relationship with them continues, and that's cool. Not everybody wants to run an IPFS node, and yeah, but the lack of sort of awareness about these caveats was kind of an issue for us, because we were seeing people using IPFS to store their NFTs, but not necessarily understanding this whole pinning process and the idea that like your content doesn't live on IPFS forever by default. So we wanted to reduce the friction to getting NFT data into IPFS, and also provide like a long-term durable data storage solution for people that are using this IPFS that is also decentralized and aligned with our mission of preserving humanity's data for perpetuity, I guess. So it's kind of a broad mission, but we're getting there. So Nft Storage is one of our answers for how this is going to work going forward. So it is a place where you can store your NFT data. It is decentralized. So IPFS and Filecoin are the underlying technologies here for not just like distributing the data, but also preserving it for long term. And it goes some way towards solving this permanence problem, where like your data can be on IPFS in this peer-to-peer decentralized network, but you also have this kind of long-term guarantee that on the Filecoin layer, that data is not going anywhere. So I'm going to talk a little bit about how the process works and what the experience of using Nft Storage looks like, and then I'll fire up a terminal and we can hack away at it a little bit so you can see what using it is like. So you just upload your data to Nft Storage, and then Nft Storage will add it to an IPFS cluster and make it available on IPFS right away. But then behind the scenes, Nft Storage is going to negotiate deals to store your data with a Filecoin storage provider, actually several Filecoin storage providers. So the way this works is the Filecoin network will incentivize these storage providers, to store the data by rewarding them with Filecoins. So you make, like at a high level, the way the Filecoin process works is you, the storage client, make a deal with the storage provider that says, I have some data for you, please store it for this amount of time. And they commit to that. And then the deal is recorded in the Filecoin blockchain. And over time, that storage provider will be challenged to say, please prove to me that you are storing a unique copy of this data. And that process is fairly involved, and you can read all about it on this Filecoin specs site. But the upshot as a user is that you can trust that for the duration of the deal, if the data were to disappear, the storage provider would be essentially punished for it. Like they would lose a significant amount of Filecoin collateral, and also it will be rewarded if they do keep it. So there's this strong incentive for them to preserve your data, and you kind of get that peace of mind that somebody out there has your stuff. And in the meantime, people can retrieve your data through IPFS and get that kind of decentralized and location independent linking property that is such a nice fit for NFTs. And you also get this, long-term assurance. And one of the reasons it's good is that if NFT storage were to go away, your data would still, of course, be on IPFS. But if all the IPFS peers who ever fetched your data went away, those Filecoin storage providers will still have it, and they'll still be able to provide it to anybody who really needs it. So you, the NFT creator, are not dependent on Protocol Labs for the continued accessibility of your data. Even if everything we've built, were to crumble into dust, you could run your own IPFS nodes or retrieve the data from Filecoin and so on, and re-provide it at exactly the same location as before, without having to rewrite any links. Whereas if you'd, let's say, if I had uploaded my data to a web server and just recorded the HTTP link, then if that web server were to disappear, there's really no recourse for the original owner of the NFT to, make that link work again, because they just don't control the domain. So it's kind of an interesting setup where now, like, you have this sort of big pool of available storage in Filecoin, and the data can be requested by this content ID that is not tied to a particular place that it's being stored. So this gives you a lot of flexibility and allows you to keep the link permanent, but also keep the actual location that the data is stored flexible. So we think that's a pretty interesting property, and it's kind of useful for the NFT use case here. So this is what the site looks like. It is Nft.Storage. It's pretty easy to remember, and you should check it out. It's pretty simple. We have an HTTP API, and yeah, you upload a file, you can see what you've stored, you can get some information about files that you have previously stored, and you can sort of check if a particular IPFS content ID has been submitted to Nft Storage. This schema is wrapped up and packaged nicely in a JavaScript client library that I'll show you in a minute. This is probably the simplest way to interact with Nft Storage, but we do also have client libraries in several other languages, such as Python, Go, and Kotlin, and everything else. Those are generated from an open API schema, and they all basically follow the same format. So if you, if you watch me use the JavaScript client, you'll understand the principles of all the others as well. So these are the various clients that you can find on our GitHub, the Nft.Storage organization. And I'm just gonna take a few minutes to show you what NFT storage looks like. So yeah, here's the site. I'm gonna log in, and I will log in with GitHub since I'm already signed in with GitHub here. You can also enter your email and it'll send you a little magic link to click on. Oh, and before I get into this, I feel like I totally spaced out on one of the most compelling arguments for using NFT storage, which is that it's totally free to use. And it's actually the storage space on Filecoin is free for us at Protocol Labs, because the value of real user data to Filecoin storage providers is actually quite high. They get increased block rewards for storing real data. So by uploading data through NFT storage, you're actually giving a valuable commodity to these storage providers, and they're incentivized to store your data even though you don't actually have to pay anything. So that's kind of nice. So anyway, here I am back logged into my files page. I can upload here, just pick a file. This little is car box is kind of interesting. I'm going to talk about the car files in a minute. This is a way to upload already sort of formatted IPFS data, and it will let you upload really large files that would otherwise hit a size limit with the HTTP API. So we'll talk about that in just a second. But generally, if you're just uploading regular files, you just hit this. You could hit this button, pick a file, and you're good to go. But most people probably won't be uploading every single NFT by clicking on a button on the website. So we imagine you'll probably be using a client library or something like this. So to use the client, you'll need an API key. And make a new one here. Let's call this Mercury. Okay. And now I have this key that will let me authorize my client. So here I am, I got an empty directory. Well, I have some images that we can toss onto NFT storage later. But we're just going to make a new NPM project. So in it, and just accept all the defaults and stuff. And then I'm going to install Nft Storage client library. It'll pull everything down. And once I have that, we'll be able to write a little JavaScript program to add stuff to Nft Storage. And okay, so there we go. And I'm going to just page over to an editor here and make a new file called index.js. And let's see, presentation mode so you guys can see a little better. And there we go. So actually, let me call this index.mjs, because that will let me use the import syntax that I kind of prefer for JavaScript. So now I can say, well, before I get started coding, why don't we take a look at the docs so I know what I'm doing. The Nft Storage doc site, this will give you, this is the JavaScript client library reference docs. So first you install it, and then we're going to import some stuff. Nft Storage, and if you're on Node.js, you won't have the file object in the global scope. So that's sort of a browser thing, but Nft Storage includes a file compatible interface. So you can import file from the Nft Storage package as well. And then you'll make a client with your token, and you can call any of the methods there. So let's grab the imports from the doc site, and we'll toss it in here. And even though this is a bad idea in general, I'm just going to hard code my token, paste it in here. Like managing your tokens is like one of the tricky bits, or you want to store it somewhere safe. In a real project, please don't check it into your source code. It's better to read it from an environment variable or some other external configuration so that you can easily replace your tokens and they're not, just sitting on GitHub for anybody to grab. But for now, we'll just say, hey, we're all friends here. Right, so back here, I'm going to grab my key and paste it in. So now I can say client equals new Nft storage token. So this is going to let me upload and call the API method and so on. So let's make a function that will store an image with Nft storage. And that's it, the path to a file. Okay. So we're going to have to read this file data in, and then we'll pass it into Nft storage. There's actually we can either use Node.js's like built-in FS module to read in the file data and construct a file object, or there's a helper library that we use in one of our other projects, Web3.storage, called get files from path. So I'm going to actually use that, but let's see. I'll show you here, repo here, files from path. Oops, oh, there it is. Sorry. There we go. So this guy is just a little helper for reading from the file system into that file object format. So I'm going to install this as well. It's bundled in with Web3 storage, but you got to bring it yourself for Nft storage. Files from path. So now I can say import get files from path from files from path. So now you give me the file name, and I can just say const files equals await get files from path file name. that actually returns an array of files because this will recursively grab all the files in a directory if you want to upload a bunch of stuff. We'll probably just point it at a single file for simplicity, but yeah. So then once we have that, there's a few different things we can use to get this stuff into IPFS. So the main example that you'll see, the first thing you see is this client.store method. This is probably, well, it's usually what I recommend everybody use. But if you're using Flow, maybe the conversation is a little bit more nuanced, because this store method will accept an object that is structured in the same shape as the Ethereum ERC 1155 metadata format. There's nothing like Ethereum specific about this. You can definitely use it with Flow, and might as well. But if you have already mapped out a metadata scheme for your Flow contract, then you can use that instead. That's totally fine. I think there's not the same standardization of metadata in the Flow NFT world that there is in the Ethereum world at this point, as far as I can tell. It's sort of contract specific. So you're going to have to sort of decide for yourself what metadata makes sense for my contract, what of that metadata belongs on chain versus off chain, and so on. So if you want to have, that said, I think that using this store method is still probably a good idea. That, like, even if you do also store metadata on chain in your Cadence contract, just because then anybody can grab it and see this without interacting with the blockchain. So it's up to you how you want to do this. But the alternative to client.store is store blob, which just takes a file or blob object of binary data and puts it onto IPFS and Filecoin as is, without any metadata manipulation that's the store method would do. And then there's also store car, which is to store those content archives I was alluding to earlier. So we'll start with store and just go through what that looks like. So it accepts, as I said, an object, and it has to have these properties: name, description, image. And then I leave this one as optional, because this is just for arbitrary key value metadata that you want to attach to your NFT. And what's kind of cool about the store method is that it has this sort of inline recursive thing where essentially, if I have a field in my metadata that is a file or blob object, the NFT storage service is going to add this file to IPFS, and then in the metadata for the NFT, it's going to replace the file object with a link to the file in the form of an IPFS URI, which is a string that's like IPFS : the content ID, and optionally a human readable path as well. So this sort of thing where you can just pass like a big JavaScript object that has these embedded files, and it will get sort of linkified for you. That happens with the store method, but does not happen with store blob and so on. So it sort of depends on your use case, which of those you're going to use. If you're already storing your metadata in Cadence and you just want to link out to, say, an image or a movie or something like that, you might not want to use store. Maybe you just use store blob. So that's kind of what's up there. For this example, we'll say, let's see. So files, get files from path. I'm gonna actually, let's just store a single file just to make this simpler. So files .length not equal 1 expected single file. And then we're just going to say, okay, files 0. Okay, so now we have a file, and we're going to call that store method and toss in some metadata. So await client.store. All right. So name, And this is something like we're going to hard code in some metadata here, but you would obviously want to have every piece of this be, user submitted or whatever. This is part of your NFT creation flow. But we're just going to say, hello, Mercury, and description, NFT storage example, and image. We'll just assume that this image, or that the file we're given is the image that is going to be stored. And there we go. So what this is going to do is take it's going to send everything off to Nft Storage service. The Nft Storage service will first store the file. Then we'll end up with a JSON object that's stored in IPFS that has these properties, and the image will be a link to the file, or the image field will be linked to the file. And then I'm just going to console log the metadata object so we can see everything that's returned. And then we'll have the main function. Okay, that it's going to be the, well, let's, process.arg v3, it'll be the first command line object. And then the first command line argument. So then we have a file name, and we're just going to say await store image file name. And then call the main function. Okay, so that should hopefully get us something we can call with node. So I say node index.mjs and give it, say, images slash this thing. Oh no. I see. Storing undefined. I think my argument reading stuff, my command line argument stuff is wrong. I think this is actually supposed to be argv2. Image must be file, blob or file object. Sorry about that. There is a parameter to, yes. The get file, so this is something I forgot about. The NFT storage image field, it really wants you to submit an actual image. And it will check the MIME type of the object. So I am actually going to say new file, give it the original file as input, file name, and then the options here, we're going to say type. Let's see, image slash GIF. Yeah, so that's one caveat, is that the store method is a little bit picky about what kind of data it will accept, whereas store blob will take anything you give it. So hopefully this will give us some, hey, it's working. No, it's not working. Oh no. Expected response with 2 entries. Got 3 instead. Well, I'm not sure what that's about, guys. Let's see. All right. There seems to be a problem with the get files from path helper, so we're going to try and use the Node.js stuff instead. So. Okay, so we're going to say content equals await fs.read file name. And then we're going to say make a new file from this content, and we'll try that. All right, so lesson learned, get files from path is maybe not live demo friendly as I hoped. This will probably take longer for the bandwidth is awful. So when I'm doing Zoom things and uploading things, I tend to get in trouble. But in a minute or so, it'll be up on NFT Storage. And then from there, it will go into IPFS and Filecoin. And we'll see once this is finished, it will return a metadata URL and some other properties of the object. While it's storing, I'm gonna just go and over to the docs so we can take a look at those other. Oh, somebody's asking. Sorry, before I move on, somebody's asking in the chat, like, what's the best and worst case scenario for upload time? So, I mean, for me, like I said, my bandwidth here is atrocious. My bottleneck is the connection between me and Nft.Storage. If you're either the super fast connection to Nft.Storage, you should get the file there with much quicker than I would. Then it'll take just a few seconds for the content to be retrievable on IPFS. And then following that, it takes about around 8 to 24 hours for the data to be aggregated into a deal. The way the deal making works is that we'll batch up lots of small pieces of data and then submit them all in one big chunk to a Filecoin provider. So it might not end up on the Filecoin blockchain right away, but within a few hours, it'll be backed up for the long term on Filecoin. But basically, as soon as you get the response back from Nft Storage, you can retrieve your stuff. So, oh no. All right, so clearly, I don't know, something's wrong here, and I feel kind of bad, that I'm leading you guys astray. My my code is blowing up. All right, let's try, instead of using client.store, let's just try using store blob and see if maybe we'll have more luck with that one. So for that, we can just pass in our file object directly, since a file is also a blob. And then instead of a metadata object, store blob is just going to return a CID string, the content ID. So let's rename this variable. So again, apologies for things kind of falling apart in live demo mode here. In hindsight, I should have run through all this offline first. But I'm actually going to try a smaller image. Let's see what we see there. So like I said, store blob might actually be a better fit for some of you if you have like opinionated metadata choices already. If you do want to use the store method, please hit me up after this, and I will figure out exactly why this broke and come back to you with the guidance for how to do it. So, hey, here we go. This one worked. We have now a content ID string. So this image is now available on IPFS, and I can go to my web browser here and we'll make an IPFS gateway link for it. So if I paste in the CID and say .ipfs.dweb.link, that's gonna go to an IPFS HTTP gateway, and it will pull the content from IPFS there. Sorry, it's loading a little bit slowly here, but that's cool. Back on the NFT storage doc site, I do want to talk a little bit about store car, because currently there is a 100 megabyte upload limit on the store and store blob endpoints. And this is just a artifact of the backend infrastructure that we use. But store car is kind of an interesting way to work around this. A car is a content archive, which is basically just a bunch of IPFS data that's already been chunked and formatted in IPFS format. And what's kind of cool about them is that you can take one big car file and split it into pieces, and then you could upload each of those pieces independently. And the backend is going to stitch them all back together into the original large file. So you can use this to submit like files of an arbitrary length. Pretty soon, this isn't going to be necessary. The client library will do all the carring for you, but that's probably only going to make it to the JavaScript client. So even if, so once that does land, if you're using a different client, you'll still probably want to understand how car files work if you want to upload really large NFT assets. So creating a car file can be done with this helper tool called IPFS car. And this gives you either a JavaScript library that you can use or a little command line tool to pack files from your file system into a car file. And then if that car file is too big to fit into the 100 megabyte limit, you should look for this thing called car bytes. Car bytes, and yeah, Nft Storage / car bytes is the repository here. This takes a big car and splits it into smaller pieces. If you do end up using this, I just want to call out that the variant that you want to use is this one called tree walk, where it's going to take the whole IPFS graph, walk through it, and then chunk it up into pieces that can be recombined into the original graph. So that's probably more like technical than you'll actually have to get, to. You probably won't have to use this. Like I said, if you have big files over 100 megabytes, this will help you out. And this is a way to get your data into IPFS. It's also, if you have a lot of IPFS experience and have already formatted your data in an IPFS compatible way, you can use this to just send it to us as is without having to reformat everything or anything like that. So that's cool. And then finally the store directory is just like store blob basically, but you can get a bunch of files and it will wrap them in an IPFS directory listing and store them all in one go. Oh, sorry, here's the thing we uploaded earlier, by the way. So this is now being served through the gateway. So nobody has to have IPFS installed to retrieve it. You can just view it on the web. If you do have IPFS, you could say like IPFS get this content ID. Yeah, so that's cool. And I do want to mention about, as I'm on this tangent about car files a little bit, there's a page on the Web3 storage docs, which is another very similar service that we run for arbitrary data that you want to store in IPFS and Filecoin that's not NFT related. But on the doc site there, we have a page about working with car files. So I want to call that out here because we don't have that yet for NFT storage. So if you are working with cars, you can go to docs.web3.storage and go to work with content archives. And all this stuff will be helpful for that, for NFT storage as well. Kind of goes through using the IPFS car stuff and all this more, advanced IPLD usage and things like that. So, yeah. All right, I think that's probably where I'm going to wrap it up and quit while I'm ahead, I guess, now that I got something to work. Thanks so much for you guys. If you guys have questions, please drop them in chat.
Yep. Thank you, Yusuf. Before you go, there's just a couple of questions that people have actually put in on the Q&A. I think one of the question is to ask you if NFT storage is like Pinata.
In some ways, yeah. There are some differences. I mean, for one, obviously we don't charge anything for storage. The other is basically just like the underlying long-term storage technology. Like Pinata isn't yet persistent to Filecoin, although I think that is something that they're interested in doing as well. And we would love to see that, of course. Like the more of these like aggregation and deal making services that arise, the happier we'll be. So I think, fundamentally speaking, like they offer a similar value proposition. So it's like an interface into IPFS that offers this like sort of persistent storage story. I think Pinata, there's, I don't know, they offer a really good service and I think you should definitely consider using them. For NFTs, I think, it just sort of depends on what kind of relationship you want with the service. Like we're happy to provide this to everybody for free, but maybe you want like more hands-on support from the Pinata team, or you have like a special, like you want your data to be stored in a specific region or something like that. Like I feel like there's definitely reasons to choose Pinata versus NFT storage, but our goal in creating NFT storage wasn't really to like eat Pinata's lunch or anything. It was just to provide more options for people to, get their stuff into this whole decentralized storage ecosystem. So, I mean, obviously we're happy no matter what service you use, but yeah. Oh, let's see.
Okay.
Please share. Oh yeah, somebody's asking for the links to the repository. So everything is on GitHub at NFT. Sorry, the NFT-storage, or sorry, the IPFS shipyard /NFT.storage is the main NFT.storage repository. And it's all the code for NFT storage is open source, so you can see how all the backend stuff works as well. Interested in that?
All right. The other question that actually popped up was to ask why the extension of that index file is actually .mjs.
Oh, right. So recently, Node.js started supporting this import syntax, where previously you'd have to say like require some package and then assign the value to a variable. And now instead you can do stuff like import NFT storage from NFT storage. This is called the ESM module syntax. Anyway, to use it with Node, like it's sort of supported by default in browsers now, but to use this syntax in Node, you can either end with a .mjs extension, or you can go into your package.json and add a field call that says type module. And then that will also enable that syntax. Otherwise, if you didn't do that and you just called it, this is just a regular JS file and you don't have type module, then instead of saying import, like let's rename this real quick to just .js. Oops. Yeah, if this is just a JS file and you don't have type module, this is going to give you a compiler error when you try to run it. So instead, you'd have to say const NFT storage, whatever, equals require NFT storage. And but I prefer using the module syntax just because it's the same in browsers and in Node. So it's just one less difference you have to keep track of.
Okay. Thank you, Yusuf, for running through us the demo as well. And for the rest of you, do continue to keep your questions coming. If you have any specific questions with regards to the demo that Yusuf has just ran, do put them in the Q&A. Yusuf will take the time to answer along the way, and towards the end, if we have some time, we will actually get Yusuf to kind of answer some of the questions live as well. All right. So thank you, Yusuf. Right now, I would just like to introduce to everyone to welcome Nik, who is the co-founder and CEO of Decentology. And he will take on to share with us for the next half an hour to share some ideas on innovation, hackathon success, best practices, that you can adopt, and also some of the tips for security, user experience, performance, and optimization. So Nik, please.
Great. Thank you very much, Justin. I'm going to start sharing my screen here. All right, here we go. Moment. So hello, everybody. My name is Nik Kalyani, and I'm the co-founder and CEO of Decentology. And for today's talk, I want to do something slightly different. I could demonstrate our product, but called DappStarter, but we have regular office hours, and my teammates, Morgan and Jacob, do a great job there of showing you some of the stuff. So what I wanted to do was take a step back for this morning's presentation and talk to you a little bit about two topics that I care deeply about. The first is innovation, and I want to share with you some techniques that will help you create an innovative solution for this hackathon. And then I want to talk to you a little bit about some best practices for decentralized applications. One of the big challenges with the blockchain ecosystem in general is that we create really great technology, but it remains fundamentally inaccessible to mainstream users because of the user experience. So I want to share some best practices that will help you improve the quality and the user experience of your application so that it becomes more accessible to mainstream users. So before I get going, a couple of things. I'm mostly going to divide my talk into these two parts, as indicated in the title: deliberate innovation and adapt best practices. While I'm going through it, if you have any questions, there is a Q&A panel in Zoom. Please ask your question there. You can also ask it in chat, but it's a little easier for us to go through if you do it in the Q&A. And next, I will pause between the two segments to take any questions you have. All right, so let's get started. So the first thing I want to do is I have 3 slides here which give you some context and about what our company Decentology does with an overview of our product. So let me show you that real quick. So our primary platform here is called DappStarter. And what it enables you to do is to very easily get started with Dapp development. So you can go to our website at dappstarter.decentology.com, and you can choose the blockchain. For this hackathon, you would choose Flow. You choose a foundation that you want to start building with. And then what DappStarter does is it generates the full stack source code for you in a brand new GitHub repository. So it generates the smart contract code, unit tests, a UI test harness so you can interact with your code immediately, and also a server-side API. And in addition, it does all the orchestration for you so that everything from starting up the emulator, generating test accounts, compiling your contracts, deploying them, compiling your client code, setting up a web server for you, and also all of that is set up to be hot loaded. So it makes it super simple for you to start your development. And we have IPFS integration also. So even that part is handled for you. So you can focus on your innovation. So you don't have to focus on figuring out which library goes where and how do you connect to a certain server and so on. All of that is automated for you. We like to think that 80% of the work is done and you can focus on the 20% value add of your application. So that's DappStarter for you. And please connect with Morgan in office hours if you want an in-depth demo or have more questions about it. So this is kind of the result of the UI harness that you get. So we automatically generate for all the transactions, etc., a great UI so you can immediately start testing it. All right, so with that out of the way, let's get to the heart of the topics for this morning. The title here is Deliberate Innovation. So I want to share with you 6 ideas for how you can create something really innovative for the hackathon. See, hackathons are an opportunity for you to think way outside the box. It is about innovation. It is about you pushing yourself and saying, well, there's a lot of these things that are done. How can I make it 10x better? Or how can I do something really, really interesting and innovative? And it's an opportunity for you to essentially think of it as a lab where you can experiment in a way that you don't normally get to do. And so with these techniques, it'll help you think of a great idea for your hackathon project submission. So the first suggestion I have is about combining ideas. So, when you look at many new innovations that occur in the world, it's oftentimes really 2 existing ideas, 2 or sometimes more, combined in a very novel way. And then you get something new and interesting. So you don't have to look for something brand new. Just look at what's existing and combine it. Let me give you an example. Prior to the era of smartphones, we didn't have such an amazing device. We didn't have a sophisticated computer in our pocket. What we did have is we had mobile phones, then we had music players with touchscreens, and we had computers. So now imagine combining all of those. You got a touchscreen, a computer, and a mobile phone. You put it all together and you have a smartphone. So that is innovation right there, but with 3 existing things. So look to combine existing things to come up with a new idea. And that is one way to come up with some really, really great ideas. All right. The next suggestion I have for you is to challenge assumptions. Very frequently, we just assume things are the way they are, and you can't change them. And that's actually not a good assumption to make. We need to, especially for hackathons, we need to innovate and we need to question everything. So it's very important that you start looking at things from first principles and say, like, is it really necessary to do this the way it's being done? And usually the answer is, well, not necessarily. It could be done differently and could be done better. For example, many of you are probably approaching this hackathon with lots of ideas around NFTs, etc. But you're also probably thinking of those NFTs as mostly static, as images or video files, etc. But there is nothing that says that you cannot make your smart contract have those NFTs be dynamic. For example, you could have an NFT that changes over time. Maybe it impacts the presentation of it. Maybe you can have an NFT that can be fractionalized, where it's not one person who has to own it. It could be owned by multiple people simultaneously. So there's many different ways in which you can look at something as simple as an NFT and say, like, what is the kind of innovation I could add to it? You do not have to make it static. You do not have to make it a simple thing. It can be quite complex. You could even have make it where the ownership of an NFT transitions through a group of people periodically. So there's lots of ways in which you can innovate in that space. All right. So the next idea I have for you is to restate the problem. So very often when you have a problem, the way you state the problem impacts the available solution domain. So if you simply restate the problem in different ways, it can open doors that you didn't even know existed. So this is a technique I use very frequently. I try and write down the problem I'm trying to solve, and then I rephrase it in multiple ways. I use synonyms, etc. And so it changes how my mind is approaching the problem. So I'll give you a simple example. Maybe you have a requirement in an application that there's multiple media files, but you can't store them as separate files. You need to store them together. And so the obvious solution there would be to like compress them, right? Make a zip file or something. But then there is the added requirement that you also need to have a preview image for those multiple media files. So now it gets interesting. How do you do that? How do you create just one file where there's a preview image and also there's multiple media files? So, well, depending on how you restate the problem, you could just say that, well, the primary requirement is that you need to show a preview image and it's backed up with additional media files. Now, you simply flipped the statement, but in that, there came a solution. Why not use the preview image as a JPEG and take advantage of the fact that a JPEG photo is also a container? You can store additional media files in it. Of course, you would have to have your web server return only the specific part of the JPEG when it's requested, but that's a valid solution. So this is what I mean by restating the problem. You essentially redefine it, and new ways that you didn't even know existed just pop onto the surface. For example, many people don't know that a JPEG image can be a container. You can store videos in it. You can store additional images in it. You can store documents in it, etc. And you can push that envelope and do some amazing things. So that is restating the problem. All right. So the next idea I have for you is many, not one. You know, one of the hardest things is to come up with an idea. It is really, really challenging. But the way the human brain works, it's really quite easy to come up with many ideas. So when you are brainstorming or trying to come up with an idea, don't try and think of that one idea, that one awesome idea that is going to change the world and help you win the hackathon. Instead, just go and start writing down ideas, whatever. Don't judge yourself. Don't filter. Don't think this is crazy. Don't think this is impossible. Don't think this is too expensive, etc. Just let the ideas flow. And what you will find is that the way our minds work, when we remove those boundaries of, okay, you got to have that one best idea, our mind just goes crazy and comes up with really, really great ideas. And so what you do is you do that. And this is also good as a team exercise. When you just start blurting out ideas and writing them down, And don't censor anybody, don't judge anybody, just let it go. And what you will find is later, if you go through that list, there will be one of those ideas, or maybe a combination of ideas using an earlier tactic that really, really is amazing and will be your idea that you go with. So this is true just about any scenario in life, not just a hackathon. If you're trying to come up with one idea, don't come up with lots of ideas, and your one idea will be there somewhere. All right, so my next suggestion is something I call reverse thinking. So reverse thinking is when you are trying to solve a problem which seems hard to solve. So what you can do is, instead of thinking of how to solve that problem, you flip it. You instead approach it like, how can I make this problem worse? How can I make it so bad that it's just unusable? Once you do that, then what you can do is flip it again and take the opposite of that, and there lies your solution. So I'll give you a simple example here. In decentralized applications, there is a problem of gas costs. Now, we don't have much of that on Flow right now, but eventually, if you build for any other blockchain, or if you have a large transaction, there is going to be a significant gas cost, and the user has to deal with that. So how do you solve a problem like that? Well, one way to approach that is to figure out a way, is to think rather, that what if the gas cost was just atrocious? What if it was $100 per transaction, or what if it was $1,000 per transaction? So that is extreme. That is something that no user would ever agree with. All right, so you've got the worst case scenario. Now flip it. What would the opposite of that be? Well, the opposite of that would be that the transaction would be completely free. So how can you make that happen? Think about that, and there lies your solution. So one way to do that is to consider that, for example, for this particular hackathon, Flow has a separate concept of a payer and a proposer. So what you could do is have the decentralized app, meaning your client application, actually pay the gas cost, and so it's free to the user. The user doesn't even need to know that there's a gas cost involved. So that's just a simple example, but this approach of taking something to the extreme and making it as horrible as possible, and then flipping that, will give you the best solution possible. And so you can start thinking about it that way. All right, so the next idea I have for you is about shifting context. So very often when we are trying to solve a problem or come up with an idea, we find it's difficult. But there's a good chance that that problem was already solved in another domain or another industry. So you can refer to that and then figure out how you can apply that to your domain or your industry to solve the problem. So let's work with an example here. So let's say that you're working to build an application that has NFT game assets, and you ideally want to make it so it's game neutral, so many people can build games using your engine, and those game assets should be tradable. Well, one of the challenges you have there is, how do you ascribe value to the game assets between games? How do you know that the shield from one game can be traded with a sword from another game? Well, you don't, and you don't want it to be arbitrary. You want some consistency in the marketplace. So how do you solve that problem? Well, you can go look at DeFi, and you can look at apps like Uniswap, etc., that have solved that problem by sort of creating a model of liquidity provider. Could you apply that kind of model to solve the problem of figuring out what should be the conversion ratio between your shields and swords from two different games? Yeah, you could probably come up with a model for that. So this is what I mean by changing the domain or industry to observe how the problem is being solved elsewhere and apply it to your specific sort of use case. All right, so those are the ideas. I actually think I glossed over one of them, which is many, not one. I actually talked about coming up with sort of many ideas. There's another example I wanted to give you is in the case of NFTs in particular. Since a lot of you are building NFTs for this, I wanted to share the idea that when it comes to sort of generative art, etc., one of the things you think about is what are the different domains, or what are the different styles of art you could generate. So you could have NFTs that, for example, decay over time, that grow over time. Can you mix art together to create a new NFT? Can you zoom into images? Can you pan them? Can you filter them? Can you pixelate them? Can you block them? So that is another example of one that is kind of appropriate. So these are 6 different ways in which you can approach innovation to come up with a really, really good solution for your hackathon project. So I will now take a moment to look at the comments and see if there's any questions about these. All right, doesn't look like there are any questions yet, so that's great. All right, so what I'm going to do now is transition to the second part of my presentation, which is about decentralized applications best practices. So all of you are about to build some sort of decentralized application for this hackathon. And what I wanted to share is 10 ideas or tips for how you can make sure that the user experience for your app is just amazing, just great, and really makes users happy to use the application that you create. All right, so the first aspect of apps that I want you to consider is waiting. So one of the problems with decentralized applications in particular is that, unlike Web 2 applications, where when the user clicks, there's almost an instantaneous response, we don't have that. Even if you have the fastest blockchain, it still might take a second or two before the user is able to get a response back. So depending on the transaction, depending on the speed of the blockchain, and depending on how many other transactions are currently waiting, it could take some time. So one of the things you want to do in your application is use any third-party APIs that are available to fetch sort of the estimated time and display that to the user. Give the user information about when their transaction is going to be completed. Most of us resort to having sort of a loading indicator, an infinite loading indicator, which sometimes is okay. But if the transaction continues to stretch on and is not completed, that can be very frustrating for the user, because they don't know if it's going to be completed in the next 5 seconds or the next 15 seconds or the next 50 seconds. So inform also the user that their transaction has been submitted, and they will be notified when it's complete, because users don't know that they can leave the page. They don't know, they fear that if they leave the page, their transaction will not work. They don't know about the intricacies of how blockchain transactions work to even know that it's okay for them to leave if the transaction is already been submitted and accepted into the pool. So it's very important you communicate this. All right, so the next tip is about impact. So one of the things about blockchain apps in particular is when there's a smart contract function and the user does something, it's quite possible that it might have other repercussions. It might change some value. It might change their standing within an application. It might lower some attribute, that value, which might adversely affect them. So one of the things you ought to do in your application is forecast the impact of the action. And I'm not just talking about, oh, when you do this, you will have purchased an NFT, or you will have transferred funds or whatever. You need to, you are most familiar with your smart contract. You know what it's capable of doing. So look beyond the immediate and obvious action, which the user is obviously aware of, but help them understand what is going to be the action. What happens next? Will this turn something off for them? Will this cause their functionality will they lose functionality? Those kind of things. It's really important to do that kind, because in most cases, because of the irreversible nature of transactions, a user could do something and then be stuck, and you don't want that. You don't want unhappy users. You want to clearly communicate the impact to them so that they can cancel and go back if they need to. All right. The next thing is events. Now, this is a very, very underutilized capability in smart contracts. All smart contracts have the ability for you to generate events, but most developers don't take advantage of them. You can use those events and surface them in the client UI and allow the user to know what is happening. So the ideal thing you would do is have client-side notifications wired up. So regardless of where in the application the user is, if some prior action has completed or has some impact on their account or their environment, that a notification pops up and you let them know what's going on. So this comes back to sort of communication. Communication continues to be one of the sort of threads that runs through this. We just want to make sure that the user is well informed at any given time. And events are a great way to do that. So you definitely want to leverage that. Flow has events, and you can have those show up in your client-side application. The next attribute or next aspect that I want to talk about is cost. So users coming from Web 2.0 are not used to dealing with a cost when they click a button or perform an action. So you want to be clear and upfront about it. You want to let the user know what the cost of their action is going to be and let them make a choice about whether they want to proceed with it or not. So this is not so much of a problem with Flow, but with other blockchains like Ethereum, especially with high gas costs, this is a problem. So in general, when you're building a dApp, try and be empathetic to the user's need to know how much they're going to spend and make sure that they have an upfront notification of that. All right, and the next term we're going to talk about is provenance. And I've been told that not many people are familiar with this term, so I'll kind of talk about it briefly. So provenance is really talking about sort of the source, tracking an object to its source. Where did it originate from? What was the history of it, etc. And so one of the things you want to do is when your smart contract is working with user data, you want them to understand where data is coming from and also where it's going to go. So when there's an interaction and you tell the user, well, this widget is going to cost you $15, maybe you need to give some insight into why it's $15 or and is there a way for them to lower that cost, for example? Or if you're, for example, showing them that they currently do not have access to something. Well, what is the root cause of them not having access to something? Can you tell them about why they don't have access to it so they understand and might mitigate and change that? So that's what I mean when I talk about provenance. Show people sort of the origin of why they don't have access or why something detrimental is currently in their environment and help them see how they can fix it. Don't have them go looking for, how do I fix this? How do I change it so I can do something that I really want to do? Show them the way. The next item is addresses. So in blockchain, as we all know, working with transactions and addresses and private keys, etc., it is the norm to see long strings of hexadecimal values. But to users, this is completely alien. They are not used to that. They are used to seeing plain text. So one thing you want to do is don't ever display raw blockchain addresses anywhere in your UI. That is just very unfriendly and also intimidating for users. What you may want to do is instead just show the first few initial characters because that's what the user is processing anyway. So I use 4 characters, but what's even better is give the opportunity to the user to sort of assign a human readable alias to it and use that instead. But in general, don't show long gibberish hexadecimal strings and things like that in the user interface. It's not pretty and it scares users. So that's a good tip to a good thing to avoid. All right, and the next item is history. So one of the things that in Web 2.0 apps that's done really well is things like breadcrumbs. Not only do you know exactly where in the app you are, but also how you got there. In a lot of cases, you can click a button and you can see how you got there. But because of the stateless nature of decentralized applications, like you literally refresh the page and whatever you're doing is gone. It's like they are single page applications typically. So users get really confused. How did I get here? What was the set of actions, or what path did I take to get here? So when you have a dApp and you're displaying a particular view, you know why the user came to that view. You know what actions should have transpired. So show them to that user so that they understand how the particular view that they're looking at came into being. So this is an important thing. It helps the user have context so they're not lost and not frustrated by, how did I get here? How do I get back? How do I undo this? Or things like that. So showing, and you don't have to necessarily show it on screen, but give them sort of an icon or something that they can click on to reveal how they got there. And that is going to be a very useful thing for users. All right, so the next item is context. So as I was just explaining, with single page applications, you might, for example, have that application respond to a blockchain event and change state. So the user is reading something, and all of a sudden the app changes state. And because it uses sort of React or any other such environment, there's no page refresh. It just kind of changes in front of their eyes. This is very, very confusing for the user and very scary in some cases, because if they might have been in the middle of doing a transaction or something like that. So clearly display a message whenever the context changes. Show the current context name prominently in every view so the user is aware that's there. If there is something dangerous that has happened, or if the transition state has caused to put the user into a sort of an environment where it's now a fault condition or something like that, change the color, make it prominent, and inform the user that something has changed. The worst thing you could do in your dApp is that while the user is using the dApp, all of a sudden, things change, like the buttons, the layout, etc., just change out of nowhere. What would be better there is to inform the user that, hey, the context has changed. Would you like to refresh the view? And let them click a button and then do that. And if they choose to cancel, let them know that they are working with stale information. So each step of the way, whatever the state is, it is your responsibility as a developer to inform the user about what is their context, what the impact is if they just continue working that context in case a new context is available, etc. All right, and then the next item is privacy. So as dApp developers, one of the things you can do is build a hybrid app where you have some Web 2.0 concepts and you have the Web 3.0 blockchain concepts. One of the things that you could accidentally or even deliberately do is take some of that Web 2.0 data, which is user information, their name, their address, their city, their state, etc., and then store it on as part of a blockchain transaction, or store it on IPFS. That data is immutable. The user did not opt in to have their information on a public resource. Even IPFS is 100% public, like just knowing the hash makes it available. So, and now there are IPFS search engines also available that are constantly looking. And so it becomes super simple for people to get access to that data. So please, I implore you, make sure that anytime there is any kind of user identifiable information, do not store it in plain text on chain. In fact, do not store it at all. But if you absolutely have to, you must figure out how you can encrypt it and what keys you're going to use. Maybe it's a shared secret or something like that. But this is very, very important. One of the things that decentralized technology and Web3 brings to the masses is this freedom from sort of the marketing craziness and the marketing assault on our privacy that has been made by companies like Facebook, Google, etc. But if we build dApps which also violate the user's privacy, then we are no better. And that sort of crushes the dream of Web3 being about privacy and about your freedom of choice and things like that. So as developers, it is our responsibility to take the user's privacy very, very seriously and not store any kind of user identified information in plain text. And the last item I want to talk about is affordance. So this is a user experience word that really, in plain English, just means don't make me think. So when you're designing the dApp as a developer, it seems a lot of things seem easy to you because you're familiar with concepts of blockchain, you're familiar with your app, you're familiar with how it works, etc. But anytime you create a UI or you create an experience where the user has to think, this is something that needs to be reworked. So please make affordance an important part of your dApp. This is easy to do by having people who are not familiar with your app try and complete a task, try and complete a basic task and get some feedback from them about what were they thinking, how easy was it, etc. So affordance is the sum total of all the things I've talked about yet. Like, don't make the user think, make it super simple for them, and make it really, really, make them really excited about using your dApp. Don't force them into complicated pathways, into complicated situations, etc. You make your dApp a joy to use and it'll be successful. Happy users talk about the dApp with other happy users, and that's how your app kind of grows. So those are all the tips I had for you today. Thanks for listening. I really appreciate it. Again, my name is Nik Kalyani. I'm with Decentology. We are the technical partners for Flow for this hackathon, and we have office hours practically every day, well, at least a few times a week. We'd love for you to come to those office hours, ask lots of questions about Flow, about DappStarter, our product, and about this new platform we are building called the Hyperverse, which is an open platform for developers to build primitive blockchain constructs, which in the future will be used by other developers to wire them up like Lego blocks and rapidly build secure, scalable smart contract applications. So thank you so much for listening. I'm going to take a look and see if there's any questions. If not, have a wonderful day. Yep. So back to Justin. Thank you, Justin.
All right. Thanks, Nik, for the sharing. And I believe that a lot of people will be able to walk away knowing how they can kind of get started, as well as to kind of have a process that they can actually follow moving forward as well. So now that we have both our speakers to do our sharing, I would just like to take this opportunity to just cover some of the components of the hackathon as part of the reminder, so that all of us would know what are some of the key information to take away while we are left with the next 4 weeks of the hackathon itself. So first of all, I would just like to reintroduce the leaderboard, which is available, and you can also make reference to the leaderboard on the participants guide as well. So how you can get on the leaderboard, first of all, is really to get on the Slack channel if you have not done so. And of course, the prerequisite is really to register for the hackathon. Once you get yourself on Slack, you will actually get 10 points for being on it, and we would like you to really be active on Slack. By being active is really about introducing yourself in the introduction channels. You can post a team photo, and also to show us your hacking progress through photos or memes and things like that through various channels that's available on the Slack workspace. On top of that, we actually do have a list of resources that we have curated specifically for this hackathon. It's also available on the participants guide that you can see. And by going through all the resources, you are able to find out what are some of the things that we recommend that you know before starting on your projects, what are some of the things that is good to know, and some of developer-based information that you can read on and to practice for your project itself. And by that, we actually do have a quiz that's actually available for you to work on it, and you get additional points for attempting. and a bonus 30 points for completing and getting all the correct answers on the quiz itself. On that, we do have mechanics of getting on social media. What we need to do is for you to leave a comment and tag 3 friends on any of our posts on Angel Hack HQ, Instagram or Twitter, Facebook or LinkedIn, whichever that you're on it. Do tag any of your friends and drop us a Slack message. Drop me a Slack message actually to let me know that you have done so, and tell me your ID so that we can identify and award the points accordingly. And also for you to share your participation of the hackathon through your own social media and put on the hashtag of Mercury Hackathon 2021. The other 2 more straightforward things will actually be attending community events. One of it will be today's Build with Mercury session, and we do have another one upcoming. And we have virtual networking in mid of this month, and later on a pitching workshop to help you craft what you should be saying and what you should contain in your 3-minute speech video. And what's in it for you is really that by being the top 100, you will actually get a walk away with $150 worth of Filecoin tokens that you can take home for yourself as well. Now that's out of the way, let me just quickly touch on the event schedule that you should be looking out for. Most importantly, we have Build with Mercury workshop that's happening next Saturday, and it's going to start at the time stipulated on the slide that you see. The following week, we do have a virtual networking session, of which we will send an invitation with the necessary links. And we do have pitching workshop closer to the submission period. And last but not least, on the 31st of October for the submission itself. So all these dates that you need to take note of can also be found on the events and schedule section on your participants guide. And that will always be a go-to guide for you for the hackathon itself. So moving forward, I'm just going to briefly touch on the Mentors Office hours. Probably some of you guys are still trying to get the mechanics of what the Mentor Office hours is going to be like. So I'm just going to quickly recap what the mechanics is. What you can do for the Mentors Office hours is really to book a 20-minute slot with any of your selected mentors using the booking system. The booking system can be found on the participants guide under the mentor section, where it will bring you to a Google Sheet for you to put in, to go through the necessary steps, such as putting your team name and the team leader's email address. And those are the step-by-steps are also indicated on the Google Sheet itself. On top of that, please remember for the team leader to actually send a calendar invite along with a meeting link so that your mentors are able to get connected with your team as well. Now, for some of you who are still looking out for a team to join, here are some of the instructions for you to know how to find a team to join as well. What you need to do is, under the Need a Team channel on the Hackathon Slack workspace, you can reach out to anyone over there, or just simply put a note to tell people that you're actually looking for a team to join. Once you have managed to find a team that you would like to join, head over to the free agent directory, which is also on your participants guide, and click on register to join an existing team on your profile. Go through the process on it to complete the form and click save, and your profile should no longer appear on the free agents, whereas you will be updated to have joined the team. If you have done that and realized that you don't appear in the same team as someone else, it's much likely that you have misspelled the team name. So what you should be doing is to go to the teams directory and search for your name, and click on update team name to make sure that the team name is spelled exactly the same way as the rest of the team members have done. So do take note that it's case sensitive. So any caps within the letter or any spacing will be critical in this case. And of course, if you want to change team along the way, you can click on change team from the teams directory and just go through the process, and you will be updated to have joined a new team. So just let me take a couple more minutes to quickly cover some the last part, which is the project submissions. Part of it, this will be the key thing that you will have to face while towards the end of the hackathon. And while you're working on the projects, just remember that your projects are being judged via 6 criteria. The first of it is really the design of the user interface and user experience of the project or the app that you are developing. Just make sure that it is something that has been well thought out of. Secondly, is really the novelty of the project, how original the innovation is. And next will be the technical complexity. What is the extent of the project's technical sophistication? And we will also judge you on the mass usability, whether this particular project that you have created is adaptable across other integrations or have a wide adoptability. Next is creativity, how unique your project is. And last but not least is the social impact on whether or not this project really fills a gap in the universe and has the potential to make the world a better place. So there are 5 submission artifacts that we are looking out for when you are submitting. First of it is a project description. Next will be a 3-minute pitch video that has pre-recorded and uploaded onto the platform, a GitHub repo link, a list of tech stack used, and a project demo link that is accessible by the public. So the process of submission will really be for you to appoint a team leader within your team. Of course, if you're hacking solo, you will be a team leader by default and head over to the platform virtualhackathon.io. And this platform will only open on the 18th of October. The team leader will then have to create an account and to select Mercury Hackathon to join that event before submitting the required artifacts on the submission page. Submissions are to be made before 31st of October, before 11:55 p.m. Singapore time. It also would mean that it's around 9:25 India time, 5:55 CET, and 11:55 Eastern time. And do remember that we do have a fresh code rule applied for all your projects, meaning that all code submitted must be written during the hackathon itself and only written in coding languages that's aligned with Filecoin and or Ipfs and of those infrastructure. Most importantly, the hackathon is really a space for us to build a community of developers who are looking to learn, to upskill, and to gain greater knowledge, and most of all, to have fun. So I really encourage you all to get connected on Slack, get interactive, and really to use this opportunity to ask people questions, to get to know different people, and really to connect with the community at all. So just a reminder that all information today that's mentioned for today's session can be found in the participants guide that is sent to your mailbox once after the registration is completed on your end. And should you need any help, specifically, you can look out for me, Justin. You can either email me over there that it's on the screen, or you can reach me out on the Slack ID that you see. The other person that you can reach out to will be our platform and community lead, who is Harish. And I'm sure most of you have been seeing Harish's messages on Slack and through the announcements as well. If you have any flow related question, do reach out to Morgan, who is from the Decentology team. And if you have any questions as regards to the Filecoin related matters, you can reach out to Lucas or Raquel, or any of the mentors that you can see on the mentors channel as well. So thank you for the time. Before that, I will just quickly check in if there's any questions from the group. One question that we have, it's actually for Nik. If Nik, you will be able to come online for a bit. The question for you is, how are dApps different from a smart contract?
That's a very good question. So the smart contract, if you were to compare and contrast it to a Web 2.0 application, represents a combination of the server-side application, API, and database. All of that is what is typically called the backend. So the front end of it is a client app that is similar to a Web 2.0 app. And the combination of the client application that communicates with the smart contract and the actual smart contract itself is a decentralized application. Now, it is not necessary that a decentralized application actually use a smart contract. For example, you can make a client application that interacts with just IPFS, and that is also a decentralized application. So a DApp in general refers to an app that works with decentralized technologies. And in some cases, if you want to be really, really specific, is also itself decentralized. So in other words, the client application is also hosted on IPFS or Saya or Weave, something like that.
Okay, thank you, Nik. So we have run to the top of the hour, and we are more or less done with today's session. What we will also do is that this session that's happening today will later on be available on Angel Hack's YouTube channel as well. So if you happen to miss out today's session, or even if you have joined us today and would like to have a review or a recap on what has been covered by both Yusuf and Nik on their respective session, you can also head on to our YouTube channel to view it and to watch it at your own time as well. So thank you all today for the time, and I really appreciate all the people who have actually registered for the hackathon. We are 4 weeks left, and I hope that you are making great progress with your projects. Do remember that we do have mentor service hours. It's happening every Wednesday from 9 p.m. to 12 midnight in Singapore time. And also that we do have developer hours by the Decentology team on almost every day on the weekdays. Moving forward, we also have a Build with Mercury session that's happening next week. We will reach out to you on Slack as a reminder as well. So do make sure that you have registered ahead of time to just get the calendar secure on it. So thank you everyone for your time today. Please have a good day ahead. If it's morning on your end, if it's at night, do have a great weekend ahead as well. Thank you everyone. Goodbye.